Hello friends, let's look at about like how to download the file from HDFS to our local system. So in last video we know how to get the file status stored in HDFS. Now let's try to download the file into our local system. For that, what we have in operation is we have the read operation and open and read the file. So the operation is uh, open. So if we copy this here and let's try to make the read operation is equal to this one, and then let's try to get the file, and then it should be uh, read URL is equal to HDFS URL plus read ops, right? So let's say response is equal to request dot get and then read URL, and then since we are reading the file, so stream is equal to true. So once we able to read the file, let's try to save the file. Open open the file, it's the data.csv, and then we should open this in a write mode, and then dot write response dot content. Okay, so if we save this and if we try to run this thing, is everything okay? Yep, everything looks fine. Python main.py. Yep, we have got the data here. See, let's try to check the number of rows here. Oh, sorry, my bad. Data.csv 1000 rows. Let's try to check the same here. HDFS -ls link down. What is the file name we have downloaded here? MNM dataset. cat link down m. So this is the content. If you try to count the number of rows, it's 1000, right? So this is how we can download the file into HDFS into local file from HDFS. Sorry. So now there won't be any issues like while downloading the small files, but when the file becomes really huge. Now let's say we want to download this full data. This is the 3.3 GB of data. Let's try to download this and let's see what issues we may face if we try to download the bigger files. Okay, so now this is the data and let's try to save it as a full data. What happens here is when we try to download the bigger file content data into our local file systems, the memory consumptions will increase. If I can show you here, let me bring up my activity monitor to check my RAM consumption. So there is a process called Python will run over here. It's not over here. Let me run this process here, and then let's check the activity monitor. Let's check it out. Yeah, so it's currently using 1.1 GB of memory, and then a 3.6 GB of memory, 3.06 of GB memory, and the file size is 3.3 GB. Now 6.74 GB of memory is being used, and this process is completed. Now if we do ls-l h, so if you see, the file is downloaded properly, there is no issues on that, but the issue is with the memory. If we download the bigger file, then we may face a problem or our process may fail. So to handle that, just if we can just tweak this little bit with open, let's call it a full underscore data underscore chunk dot csv, and let's write those, and then as fin, and then for now let's save it in a chunk wise, not all the files is together. So chunk in response.iter contains here chunk size is equal to, I am giving like 1 MB, but you can give it to like 2 MB, 3 MB, and you can check it on this way. 1 MB to bytes, full value it's 1048,576. so let's write down 1048,576. so I want to chunk on this label, and then just f in dot write, and then you can write it here the chunk. Okay, so this way the same file will be downloaded. Now the file will be like full data chunk, and now we will check the memory uses for this particular way of downloading the file. Now ran full as ran. If I now check, now it is using 30.6 MB. It should not exceed more than this, and you will see the process here. It's still executing. Now it's completed, so the memory consumption has not increased. So this is the way to download the larger files from Hadoop, from HDFS to our local systems. Thank you.